Scenario: the International Space Station with mass ms is orbiting Earth about 400 kilometers above Earth's surface. Given Earth has a mass of me and a radius of re, the question: what is the correct equation for the gravitational force exerted on the International Space Station at any given time? The answer: the basic gravitational force equation for two planetary-sized mass is defined by Fg is equal to the big G m1 m2 over r squared. So let's plug in the variables in the given situation. It should be force gravity is equal to that big G. The masses on top is ms and me divided by re squared. This should be the gravitational force between these two planetary-sized masses. This is actually incorrect. The reason why it's incorrect is this. The r value needs to represent the distance from the center of Earth to the space station. So here is Earth. Here's the space station that is orbiting it. And the RE, the R has to be the entire thing here. This has to be R. However, the RE here just represents from the center of Earth to the surface of Earth. So that is just RE. It is missing the rest. It is missing the 400 kilometers. So the entire radius or the entire distance between them is RE plus the 400 kilometers. So the correct answer would be this. Fg is equal to G, ms and me is on top. On bottom, in the parentheses for the r is 400 times 10 to the third plus re. You're wondering, why is it times 10 to the third? Well, the units for the big G is in meters. So you have to convert the 400 kilometers into meters, which becomes 400 times 10 to the third meters. That's the reason why it's written like that. Please note that the 400 times 10 to the third plus re value here represents the distance from the center of the Earth to the space station. So this will be the correct gravitational force equation for the two planetary-sized masses.